In this section, we go over the inference about the two means dependent sample. So this one is your 9.4 in the textbook. In the last video, I went over section 9.2 in your textbook. So again, this chapter is also has the proportion and the mean, and also the last one is standard deviation. So the first section of the chapter we went over in the last video is 9.2, the two population proportion. Now the next one should be 9.4. So in your textbook, 9.3 is about the independent sample, but I want to go over the dependent sample first in the package, and then in the next video we'll go over the independent 9.3. Now the last two chapters, let's recall, we only talk about the one sample, and we analyze the hypothesis for the proportion, the mean, and also standard deviation. Now in this chapter 9, we will compare the two samples, not one but two. So that's why we compare the two means, the two proportion in the last video. Now the two means dependent sample. The next video, the two means independent sample, and the last one should be the two standard deviation. So we collect the data from the two samples, and then we compare or we analyze the hypothesis of the two samples. Not one sample as in the last two chapters 7 and 8, but now it is two samples. Now dependent samples are the sample that when you pick one data, then the remaining data should depend on the one that you pick. For example, if I compare the income of a family, then if I pick one husband incomes, then in order to get the family incomes, then I have to pick the second data, which is the wife income, and that wife income has to depend on the husband because they come from the same family. So if you pick one data and the next data, you have to depend on the one you just pick, then they are dependent sample. Now the first objective is to test the hypothesis regarding the mass pairs data. So statistical inference methods on the mass pair data use the same methods as inference on a single proportion or the mean, except that we are comparing the differences on the two samples. Now there are some requirements to test the hypothesis regarding the mean. This is the mean for this section. The mean difference of the mass pair. The following requirements must be met. So the sample is obtained using the simple random sample. So this must be always be true. They are dependent for this case, and the differences are normally distributed, or we don't want any no outlier. Outlier meaning that if I have one data here, here, and here, they are close and related to each other, and there's just one data is far away from the common data, then this one is the outlier. And the sample size must be bigger than or equal to 30. So remember, we have three cases: proportion, mean, and then standard deviation. Now the last section 9.2 was about the proportion. Now this mean there are two cases. One is dependent and the other one is independent. And dependent we are covering in this section. The next section is about independent, and the last one should be standard deviation. Remember, from chapter 7 and 8 for the mean, we also have dependent and independent, right? Or small size sample versus large size sample. So now let's go over the first objective. Now, conducting a hypothesis rewriting the difference between the two means using a mass pair design. In order for determining the nose and alternative hypothesis, the hypothesis can be constructed in one of the three ways, where the mu d represent for the population the mean difference. So when we compare the two samples, we are comparing the difference between them. So mu is the mean, d represent for the difference between them. Let's say I have the mean of the sample, the first sample, and the mean of the second sample. Now, if I want to compare the mean, I take the difference between them. So that's why this one is the difference of the mean between the two samples. So UD is the difference of the two mean of sample 1 and sample 2. So we call that the mean difference. So we always compare the mean difference, whether that they are equal to 0 for the null hypothesis or they are different for 0, which is the two-tail. If the mean difference is less than 0, then we are considering that for the left tail, or bigger than 0 or for the right tail. Remember, pay attention to the error. If it's pointing to the right, it is a right tail. If it's pointing to the left, it's a left tail. And we are considering them against the 0. Pay attention, this is a 0. Okay? So the mean difference, that means we take the first sample mean, subtract the second sample mean, and the null hypothesis is always equal to 0. But then the one that we are testing again is whether this is non-zero or two tails, less than 0, left tail, or bigger than 0 is right tail. Usually they will give you the level of significance, and this is based on the seriousness of making a type 1 error. And we saw this many times before in the last two chapters. And before we can compare or we can reject or we can accept the alternative hypothesis, we must find a p-value. And if the p-value is less than the significant level, then we reject that. Okay. Now for the mean, the same thing. You have to first find the test statistic. The mean, we do the test statistic. The proportion excuse me, the proportion, we do the z statistic. And for the standard deviation, we do the chi-square. So proportion is z statistic, the mean t statistic, the standard deviation chi-square. Okay. So now the test statistic or the t statistic for the mean is T naught. D bar, meaning that the mean of the difference. Okay, the difference of the mean. Now SD is the standard deviation of the difference. So when we talk about the two samples, we are talking about the difference between them. Okay, so this word is the difference. So this is the mean difference. This is a standard deviation difference, and then it's just the sample size. And the same thing, we are using the TCDF for the t statistic, right? And two tail, make sure you multiply that by 2. And the common for TCDF is a low bound, the left one. The upper bound is the right one, and make sure you input the degrees of freedom as well. And if the p-value is less than alpha, then we reject the null hypothesis. Now let's try the very first example. So in this example, we are testing a claim regarding the two pairs. So the following data represent for the cost of a one-night stay in the Hampton hotels and the Quinta hotels for a random sample of 10 cities. So we pick 10 cities, and in each city we take the two data of the two hotels. Now we want to test the claim that the Hamptons are priced differently. So the keyword here is the differently. Differently meaning that the sample, right, or two-tail. Now we want to compare that the Hamptons, they are priced differently comparing to La Quinta, and alpha is 0.05 for level of significance. Now in order to test the before that, this is a match pair because we're comparing two sample data, and the prices, they are coming from the same 10 city. So in each city we pick one for Hampton, one for La Quinta. To test the hypothesis, we first compute the differences. Again, the key word here is the difference, right? The difference between the two samples. So before we do anything, we must find the difference between them, and then we then verify that the differences come from a population that is approximately normally distributed with no outliers. And because this sample is coming from the small data, right? The small sample size. Because we only take 10, in this case n equal 10, but the requirement is n must be bigger than or equal to 0. Therefore, we must verify that there's no outlier. If this is bigger than 0, then we don't need to care about the outlier. So here you can follow this instruction to find the difference for the two data, or I can just subtract this one and here, and I get a difference, right? The difference meaning that I take the mu1 or the first sample, subtract the other sample. So 129 subtract 105 give me 24. Subtraction, the difference between them. 129 subtract this, I got 53, and I do the same thing for the rest. I should get 40 here, minus 10, 71, 77. Subtract this to this, right? And 129 subtract 59, that's 70, 39, and 50. Now that's they are the different. Now checking the requirement for no outlier. Usually I'll give you just the answer for this one, so you don't have to construct a box plot. And usually for this class, once we ask you for something, then they should be meeting this requirement, so you don't have to worry about that. Now the hypothesis test setup. So the null hypothesis, remember, the null hypothesis, they are always equal to 0, right? So in this case, I put the mean difference is 0. Now versus the alternative hypothesis. Remember, in this case it's 2 tails. That means it is non-zero for the alternative hypothesis. 2 tails meaning that the equal side turn into the different or non-equal. Now we are given alpha, and the next step is to find the test statistic. This one is the mean difference. This is the standard deviation difference. So in order to get d bar or SD bar, I have to go back to this difference here. This is the difference between the two hotels, and we have 1, 2, 3. Now we have one single value data here, and d bar is basically just the x bar or just the mean of those 10 data here. So we add 24 53, 100, 40, 40, and add all of these and divide by 10 to get the mean. You can do that by TI-83, 84. You should get 51.4, just the mean of this guy here. Now standard SD, or the standard deviation difference. Again, you take this whole 10 data and put that in your TI-83, 84. Find the standard deviation. It should give you around 30.8336. Okay, so that's how I get the data. Now come back here. We just found the bar above to be 51.4. SD is 30.8336, and there's 10 data, so square root of 10, and this is to be 5.27. So after you find the test statistic, now we need to find the p-value. And remember, this is the two-tail. So let's draw the curve so that you don't make any mistake. So this one is the t statistic, and we got 5.27, right? This is the two-tail. So we got the test statistic to be 5.27 because this is the two tails, so one is on the right for 5.27, the other one is minus 5.27. So two tail, we are looking for the two value at the two end point. So in order to get this value in here, again, for the p-value, because we're using a positive value, right? So we just take the TCDF, and the left bar is 5.27, and go all the way to the right, which is 10 to the 99, right? Extremely large value. And then the degree of freedom, or 10 minus 1. And this one is only give you this whole region here, because this is the same thing with this, because they are symmetric, right? Therefore you just need to multiply that by 2 for the two tails, and you get that to be 0.00051, and this one is less than the alpha, because alpha is 0.05. Because this is less than alpha, therefore you're gonna reject the null hypothesis. If you reject, that means there is sufficient, right? There is sufficient evidence to conclude that the price of the Hampton, they are different from the La Quinta. Because we reject the null hypothesis, meaning that we accept this one, right? We reject this one, that means we accept this one. And we accept this one, meaning that we say that the price, they are different. Because the price, mu d, meaning that mu1 minus mu2, right? If we say that they are not equal to 0, this is for mu d. We accept this one. That means we say that this one is not equal to 0. Or if you move mu2 to the other side, meaning that the price now should be different. So we say that yes, the price for the Hampton is different from the La Quinta hotel. Now the next objective is to construct and interpret the confidence interval for the population mean, the mean difference of the two pairs. So this is the formula for the lower bound and the upper bound. Again, this is the different mean and the different mean, and this is the t. This is alpha over 2 not alpha, and SD is the standard deviation, the difference of the standard deviation. we already found D bar and SD above, so you should know that. Now let's try this last example for this section, constructing a confidence interval for the pairs. Now we want a 90% confidence interval for the mean difference. The mean difference meaning that mu D, the mean difference in the price of Hampton and La Quinta. So we already verified that the data they come from the population with no outlier. Now we want to find the confidence interval, which means we want to find the lower bound and the upper bound. Now in order to find the lower bound, right, we need to find T of alpha over 2. Now alpha is 1 minus 90%, in this case, which is 0.9 or 0.1. Alpha over 2 is 0.05, and the reason we want that because we are looking for T alpha over 2 in this formula, and that means we are looking for T of 0.05, and in order to find the T of 0.05, use this command in TI-83 or 84, INVT, inverse T, and 1 minus this value here, or 0.05, and the number of degree of freedom, or 10 minus 1. There are 10 data here, and you can find that to be around 1.83. We already know the D bar and SD, which is here. D bar is the mean of the difference here, and SD is the standard deviation of this data here. So let's wrap those two values there and find the bound here. So the bound, I have the lower bound, which is this guy, right, with a minus. So we have D bar minus T alpha over 2 SD over square root of 10, or 51 minus 4 minus 1.83 from here for T alpha over 2, and then 30.8336 over square root of 10, and you're gonna find it to be 33.524. Now for the upper bound, you just change it to the plus. So plus T alpha over 2 SD over square root of 10, or again this one change it to the plus. So 51.4 plus 1.83, 30.8336 over square root of 10, and that's equal to 69.274. So we found the upper bound to be this and the lower bound to be this. So upper bound here, lower bound here. So we are 90% confident that the mean difference in the hotel price is falling between this value and 69.274. Okay, so that's is the end of this section, and this is just some extra TID for instruction if you like to explore more. Okay, so that is the end of this video. In the next one, we'll be talking about the independent sample.